When a radical is in the denominator, remember this is one of the three things that we have to take care of if we want to simplify uh, a radical expression. So when the radical is in the denominator of a fraction, I have to do something with it. I think the example I had is 1 over root 2 is no good. So I want to get rid of that radical. I want it to be a whole number in the bottom. Well, what I have to do is I have to multiply it by something to make it a something that I can take the square root of. And I use the product property there. 2 times 2 is 4, so I have the square root of 4, and we know that we can take the square root of that. Thing is, if we do it to the bottom of the fraction, we also have to do it to the top. And thankfully, 1 times root 2 is not bad. It's just root 2 on the top. Square root of 4 is 2, so we have root 2 over 2. And there is how I rationalize the denominator. That's what I'm trying to do there. So I'm trying to be strategic about what I multiply the denominator by to make sure that I get rid of all the radicals. In part A, you can see I have a root 3 in the bottom, so I'm just going to multiply by root 3 over root 3. And I end up with 2 roots of 3. Root 3 times root 3 is root of 9, which just gets me 3. Now, if you do this properly, if you have the square root times the square root again, the square roots just disappear and you're left with the radicand. But really what's happening in the denominator is you have root 3 times root 3, which is the square root of 9, which is 3. I just skipped this step in the middle. If you choose the right radical, it'll always just cancel out the radical and leave you with the radicand. All right. Now, for part B here, I have the square root of 18. So I could just multiply the top and the bottom by the square root of 18. The thing is I'm going to have to reduce a fraction there. And I notice from previous problems that I can actually split the square root of 18 apart into the square root of 9 times the square root of 2. Well, I know what the square root of 9 is. It's 3. 13y is all in the square root there. Now, by simplifying the denominator first, I've made my life easier. Now I only need to rationalize with root 2 over root 2. And I get the square root of 26y over 3 times 2, or the square root of 26y over 6. I can't take the square root of y, and I can't take the square root of 26 or even reduce it down at all, so that's why I didn't mess with the numerator. But I do have to keep track how that numerator is changing. I had to multiply 13 by 2 using the product property. But by simplifying that denominator first, I've made it easier on myself. I could have immediately, and this is, alternate method here, done 13y over root 18 and multiplied by root 18 over root 18. What would have ended up happening, though, is I would have had 13 times 18 times y. Well, I could still reduce that 18, right? Turn into 9 times 2 there. Take the square root of 9. I get 3 times 13 times 2 y over 18. Guess what the 3 and 18 reduce down to? 6. And 13 times 2 is 26y. So I still could have gotten there. I just would have had to reduce a fraction at the end. So it's better to simplify it first, simplify the radical if you can, then rationalize, than it is to just rationalize and then have to reduce later, in my opinion anyways. But either method technically will work. Just one might be a few more steps than the other.